In discrete mathematics, often we are counting number of ways to do something. So let's do one interesting problem about counting number of ways. In this example, we have frogs at the edge of the pond. It wants to cross the pond. Now we put some kind of constraints over here. So the frog, it can jump in certain ways. So the frog can jump on the stones in the pond. Suppose like it can jump directly from one stone to the next stone, or it can make a bigger jump by skipping one stone or skipping two stones. But it cannot skip three stones or more. So in how many ways it can cross the pond? So suppose we write down the number of ways as x. X is number of ways to reach to certain stone. Suppose there is kth stone, so reaching to kth stone is xk. So suppose it's like first stone, so reaching to stone number 1 is x1. Reaching to stone number 2 is number of ways are x2. So we want to count in how many number of ways, different kind of sequence of his jumps, he can reach from one edge of the pond to the other edge. So let's write it down. It like x1 is equal to number of ways to reach to first stone. So x1 is like there's only one way to reach to first stone, that somehow it reached. For example, we just place it on first stone. Let me draw the stones over here. This is stone number 1. So we put frog. I'm just drawing my own frog. Suppose it's like stickman frog. So this is stone number 1. At some places we can call it like stone number 0, but over here let's call it stone number 1. And this is stone number 2. This is stone number 3. Suppose stone number 4, and so on. We keep on going ahead. So in how many ways it can reach to stone number 1? We just place frog on first stone. So there is only one way. So we write it down, x1 is equal to 1. There's only one way to reach to stone 1. That somehow we place it there. Our frog somehow came and sit down on first stone. How can it reach to stone number 2? Remember, it can jump directly one stone to the other, or it can skip one stone, or it can skip two stone. There's no need to skip over here to reach to stone number 2. There is only one way, like it will jump from stone 1 to stone 2 and it will reach there. So x2 is 1 in a single hop. Frog can reach from stone 1 to stone 2. In how many ways it can reach to stone 3 from stone 1? So it can jump from 1 to 2, and then it can jump from 2 to 3. This is one way of reaching here. Or it can jump directly from stone 1 to stone 3. So there are two ways to reach from stone 1 to stone 3. So we write down x3 is equal to 2. Two single hops and a double hop. In how many ways we can reach to stone 4? So we just extend this one. So one way is to come to stone number 2, 3, and make a single jump to come to stone 4. Or it can make a double jump and then make a single jump. This is another way. Or it can make something like single jump and then it makes a double jump. So this is third way. Or I can draw like on the other side. So it can skip two stones and it can directly reach to stone number 4. So there is one way, 2 way, 3, and 4. There are 4 ways it can reach from stone 1 to stone number 4. This one. And how many ways it can reach to stone number 5? So let me put another stone here, stone number 5. So now it cannot jump directly from stone number 1 to stone number 5. It has to extend wherever it was before to stone number 5. So suppose it is on stone number 4. So it will simply jump from stone 4 to here. This is one way of reaching from stone 4 to 5. So whatever number of ways he was reached to stone 4, it just jumped directly to 5. So there were x4 ways to reach to stone number 4, and then it jumped to 5. Or from x3, it can jump like one jump over here, but then it's reached to stone 4, and we already counted this way how to like reach to stone number 4. So we won't count it here. From stone 3, it come directly to stone number 5. So there are x3 ways to reach to third stone and then directly jump to x5. So when we are directly jumping over here, we are not adding any new way. And from stone 2, if it jumped to stone 3, but we already counted in x3, in how many ways it reached to stone number 3. It can make a double jump to x4, but in x4, we already counted this thing. What is not counted and which will be new over here, if it jumps from x2, position 2, directly to stone number 5. So there are x2 ways to reach to stone number 2, and then just adding no additional way, but just directly jumping from 2 to 5. So it is just like x4 times 1, x3 times 1, x2 times 1. Like this, an additional jump is not adding anything, but we are just multiplying it with 1. Or if you don't multiply with 1 to avoid any confusion. So total number of ways to reach to stone 5 is, so x5 number of ways to reach to stone 5 is x4. In how many ways we reach till stone 4 plus x3 plus x2. In how many ways we reach to stone 3 and stone 4. So this is, we have got x5. So in general, if we are somewhere in the middle, so we are at kth stone. So in how many ways we can reach to stone number k, xk. So what is xk equal to? From k minus 1 stone, we can directly jump here. Or from k minus 2, we can directly jump to x to stone number k. Or from k minus 3 stone, we can directly jump to stone k. So in how many ways we reach to stone k minus 1, we must have already calculated. This is xk minus 1. Number of ways. In how many ways we have already reached to stone number k minus 1 is k minus 2. After that, we are just directly jumping to kth stone. And in how many ways we reach to k minus 3 stone is xk minus 3. So to reach to xk, we simply add all these things. So xk, number of ways to reach to stone k, is addition of previous 3 number of ways, xk minus 1, xk minus 2, xk minus 3. If you are familiar with Fibonacci sequence, so we can say like, this is something similar to Fibonacci sequence. However, what is the difference is in Fibonacci sequence, we add previous 2 terms. So in Fibonacci sequence, let's call it f. Fk is equal to Fibonacci sequence. So its kth term is fk minus 1 plus fk minus 2. So this is Fibonacci sequence. Our problem is a bit generalization of Fibonacci sequence, in which instead of previous 2 terms, we are adding previous 3 terms. For this kind of problem, these are called recurrent problems. So in which we calculate new term based on the previous terms. So it's good to look at, for example, Fibonacci sequences are Catalan numbers.